Very good, Ryan. So it is 879. So carry 8 plus 8 plus 3 is 19. You carry the 1. 1 plus 1, 2, 9, 8, 17. Carry the 1 again. 2, 3, 4, 8, 8, 7, 9. Right, so that should be fine. We'll discuss this. Actually, I'll just put the answers in because this is basic concepts already. Just wait for everyone to submit answers. Yep, very good, Sarah. That's correct.
Thanks.
And I'll put the answer up now. And if you haven't got the answer, just keep working. And if you get the same answer, this should be 3741. All right. And the next one should be 2996. And it's the same process again and again. You're just adding 343 and 3398. You get 3741. Vertical addition at each column. I keep confusing columns and rows, but let me know if I missed those again. And then again, same thing. You can do them separately, or you can do them together. Right? And then for this question, you just keep adding 3 plus 3 plus 4 plus 6 is 16. So you put the 6 and carry the 1. Keep doing like that, and you should get the answer in the end. Right? So yeah, we'll move on to the newer content. This is revision anyway. All right. So there's a rule in maths that whenever you have an equation or an expression in maths, you should go from left to right. You guys know that rule, right? So always go from left to right, except there are a few exceptions, right, to that. Don't do it all the time. The first one is another rule that's more important, which you already know, which is speed math. Right? Because if you see multiplication to the right, you should do that first, even though there's maybe addition to the left of it. Right? Because multiplication is more important. Because multiplication comes before addition and subtraction. Right? So that's one. But there's also another way where we can learn about the properties of addition, subtraction, multiplication, division. It will allow us to break this rule sometimes to make it easier for us. That's the rules we're going to learn today. So these rules, we don't have to break them. We can add them normally. But then when we break these rules, it'll be convenient for us. Right? It'll be a shortcut for us. It will save us time. That's the point of using these rules. So when there's complicated additions, we can learn some techniques to we can make addition easier by rearranging the sum. Then we might not even need to do long addition. It might just be super easy for us to add it directly. Right? So by the end of this chapter, you should be able to quickly solve problems like this. No long addition needed. Can you guys think of a way to do a question like this with that?
Can't you add in going from not like the columns, like the value ones to the other side ones? Yeah, I think so. I'll just try to do it. 234 and 4 is like the ones. You can add 3 because that's the ones of 83.
Oh, okay, yeah, I see what you mean. Close. Yep. What about you?
I would maybe add 70 to 83, make 100.
Yeah.
And then I'd add 100 plus 234, 334. And I'll just add on 86 to that.
It was 66.
Oh,
yeah. That's all good. You're right on the point there. Idea is to pair them up. Actually, you can pair this two together. It's 234 and 66. What is that up to? 300. You have 300 here, and 83 plus 70 is 100. 300 plus 100. Super easy. You don't need long addition for that. So we pair them up to get nice numbers. So what you need to do is look for pairs that add up to zeros. Right? And then I'll explain these in more basic properties we're going to learn. Just commutative property, associative property. They sound scary, but they're not. They're pretty simple. Right? Okay, we'll get started on those properties. Okay, so first of all, super easy question. What's 8 plus 12? 20. What's 12 plus 8? So my question, yeah, very good. Does it matter the order which you add the numbers? No. That's the first property.
It's the same.
Yeah, very good. So order doesn't matter for addition. And I know you guys already know this, but we use this in more clever ways later on, okay? So this is a commutative property. It says commutative means changing the order doesn't matter, right? So when you have the commutative property of addition, it means for any two numbers, so A and B, we can use sort of algebra, not really. A plus B is same as B plus A. Because any two numbers, rearrange the order doesn't change the addition, right? And we can watch the video. The link work? Nope. I have to go on another file. Sorry, give me a second. This video now. Yeah.
Ice break. Choose your strength. Ice break. Real coffee recharge. Ice break. Bring it on.
Give me a second. For those online, can you guys hear the audio?
Yes.
All right. Okay, that's good.
Today we're going to talk about rules. Now I know, you don't like rules, but you're thinking about home rules. And home rules are always about what you can't do. Math rules are better because they're about what you can do. Now I'm going to start with one of the simplest rules of addition, the commutative property. We'll start with an example. I'm going to count some hats here. I've got 2 floppy hats, 3 fuzzy hats. That sounds like 2 plus 3 hats. Of course, it's also 3 fuzzy hats and 2 floppy hats, so that's 3 plus 2 hats. Well, it doesn't matter which order I count the hats in. They're the same number of hats either way. So these two have to be equal. And there's nothing special about 2 and 3. Could write 4 plus 5 is 5 plus 4. 9 plus a million is a million plus 9. We don't want to have to write down all those equations as rules. What we want to do is write down just one equation that stands for all the possible equations that tell us that it doesn't matter what order you add the two numbers in. And to do that, I'm going to use variables. And a variable is a letter that stands for a number. So I'm going to write A plus B. And each of these letters is a variable that stands for some number. And we can choose whatever number we want to put in there, like 2 and 3. And what the commutative property tells us is that it doesn't matter what order I add these in. A plus B is the same thing as B plus A. Nice and simple, and it makes sense. And that's one of the great things about math rules. Math rules make sense. Because rules that don't make sense, those are bad rules. But don't tell your parents you heard that from me.
So hopefully that made it a little bit more simple. I think you already sort of got it, right?
Yeah.
That's. By the way, I know the video doesn't match the audio exactly. Is that fine for you guys?
Yeah, it's fine.
Fine. All right. And you guys fine as well? Yeah. Okay. So actually, go my good notes. So I'll show you a visual of it as well, right? Just like that. If you look at these sort of counters, right? Another copy is black and white, so you might not see the difference. But why isn't it writing? Okay. All right. All right. Actually, just give me a second. Close it. All right. So if you look at this, if you look at like the sort of counters, you can there's 7 of them, but it can be like, oh, there's 4 green plus 3, 4 plus 3, or you can do 3 yellow. Sorry, 4 green plus 3 yellow, or 3 yellow plus 4 green. It doesn't really matter the order you added it. It's always going to be 7 regardless. Sort of visual way to see it as well, right? Okay, so now we're going to do a little example. I know you can do this without normal way, but you rearrange this addition to make it a bit easier. Some of them you can probably do already. So for example, I'll go through this one, all right? For the first one, I know you guys know how to do this normally, really easy numbers. But to make it even easier, what we can do is we can rearrange it to make it 23 plus 17 plus 8. So switch the 8 and the 17. Then you have 23 plus 17 because they add up to 40. And you plus 8, and that's 48. So in general, you should be looking for numbers that pairs that up to zeros. So for example, we have 1. You want to pair that up with it. What do you add to 1 to get something that adds with 0? 9. So you pair it with a 9. You have a 2, you want to pair that with it?
8.
Yeah. And 3, 7, just like we saw. 4, 6, 5 with 5. If you're going to pair these numbers, it'll make the addition a lot easier. So for example, here we see 234, 83, and 166. You can rearrange and get 234 plus 166 because they pair up nicely. Plus 83 ends up being 400 plus 83. So it's a little bit easier than just adding it directly. So we'll do a quick example. Okay, it should be still easy addition. We don't have to do it, but use the shortcut method so that we can, when we get to hard problems, shortcut method will be a bit easier to use. So don't just add it left to right, rearrange it. Okay, Ryan and Sarah. So they rearrange so they get nice pairing numbers. Then add them together. Okay. And then you get the concept. Good. Just forget that. Okay. Ryan, what's your answer to part A?
138.
Yeah, good. And did you rearrange so they get 7 plus 73 plus first?
Yeah.
Yeah, good. This is a nice number. It's 100 plus 38 then. I know you can do it normally. It's not too big, right? You can still do it the easy way. Not the easy way, the left to right. But I just want you to use this so that when we get to hard problems, you can use it, keep using it as well. All right. And Sarah, what did you get for part B?
383.
Very close. Not exactly. All right. So if you rearrange it, 134 plus 166.
Oh wait, I did a different one.
Oh. Or did you do this one?
Yeah, that's what I did.
Okay, that's close as well. It's extra 3. It's not 3 though. Remember, because 234 plus 166 adds up to 400. Then you're an 83. All right, so that's very close. You got the idea. Just small silly mistake. That's fine.
Yeah.
Okay, that's good. But for this one, you put 134 plus 166 first. Then you're the 89 after that. All right, so you get 134 plus 166. That's 300. And you're an 89 on top of that. That's 389. That should be our 2 answers. Okay. All right, next thing, associative property. What do parentheses or brackets, we should probably know, just brackets, what do they mean in maths?
You have to do it first.
Yeah. You do the things inside brackets first. Just first rule about bid maths as well, right? Brackets first. So in this case, we have to ask to do this calculation. You do what's inside brackets first, right? So let's go to this example. What's 8 plus 12 plus 11? But you have to do 8 plus 12 first. Yeah, it's an example. It's an easy one, so it's fine if you just say it as well. So you do 8 plus 12 first, that's 20. You add 11 onto that, that's 31.
31.
Yeah, good. And if you do 8 plus 12 plus 11, the answer is still going to be 31. So here, didn't matter what we did first. So in the brackets, we can do 12 plus 11 first, or we do 8 plus 12 first. But regardless of what we did first, always end up with the same number. Right, which you probably already know. Yep.
But in multiplication, doesn't it like matter like what you do first?
Not for multiplication.
Because sometimes you can get a different answer. Oh, yeah.
Was multiplication and addition?
No, like
If it has different word mass like division and multiplication,
Oh yes, yes.
you have to do the brackets first. Or
Exactly.
you
Yeah,
have to do
that's
the
correct. So, but this
multiplication.
just for addition, you don't need to worry about that. That's the point. Yeah. So you guys are correct that if there's more than one operation, if there's multiplication, addition, a lot of those, order does matter. But I'm just saying, just for when there's addition only, you can rearrange it. It doesn't matter what you do first. You can do any addition first. So does that make sense?
Yeah.
All right. So the point is that it doesn't matter which of the two additions we do first. Just for addition, not for other operations, just like you guys said. Right. So order of the additions don't matter. Which what you do first doesn't matter either. Right. And this is in general, it's true that if you do have 3 additions, A plus B plus C, it doesn't matter if you do A plus B first or if you do B plus C first. Just for addition, not for others. Sorry. So that's the associative property of addition. Right. And we're not going to watch the video because I think you guys already get the idea. And do you guys have any questions about this property? Or does it make sense? By the way, if you have any questions, please let me know, because later on, I want you guys to be solid with foundation, because we're going to have hard problems. Okay. All right. So next thing is the visual of it, right? Here, if you add these sort of blue and orange dice first, there's circles first, it doesn't matter. If you add the green and the orange as well, right? So it doesn't really matter the order we do it in. Okay. So this property says then when we have brackets when we have only addition, right? Import only addition. Expression the only addition, brackets don't mean anything. So other operations, no, we can't do this. But if it's only addition, you can brackets don't mean anything. So you don't have to do the ones in the brackets first. You can do them second or third or whatever. But you can break the rule, I guess, when you have just additions. Yeah. So when we combine this with the commutative property, we can rearrange any expression in any order. So then we can add anything add it in the order, any order we want. That should make it easy for us. Right? So left to right doesn't matter. Right? So for example, actually, I'll explain how we use this first. When we use this is we rearrange sums together. You guys will probably already do this to add together numbers that pair nicely. Right? We call that, for example, here we rearrange this to make it 3 plus 7 plus 8 plus 12. Because they pair nicely. 3 and 7 pair nicely, and 2, 8 and 12 pair nicely. So you end up with 10 plus 20 equals 30. That's a lot easier than doing directly left to right. Right? And it'll still be pretty easy because it's 1-digit addition, but this will just be easier by rearranging it, right? So this is the example we saw at the start. Right? For this example, we can rearrange it to get 234 plus 66 first. And then we also rearrange to do pair 83 and 17 together, right? And then we add them up together, end up with 300 plus 100, which is 400. So I'll give you guys 2 examples to do on your own now. So let's go to this one. Let's see how to do this. Exercise 1.1.3. So we're doing both of these, A and B here. So rearrange it to make it nice numbers. Okay, so we'll go through the first one now. Imal, what's your answer to this question?
Number 1.
Yeah, number A, part A.
110.
Yeah, very good. Right. The way we should do this is to rearrange this way: the 21 and the 49 together. We pair the nice numbers together. Pair the 30 and the 27 together. Right. And the 21 plus 49 is 70. Plus 13 plus 27. That's 40. That ends up to 110. Right. So that's good. So does that make sense, Ryan and Sarah?
Yeah.
Yeah.
For B, Johnny, what did you get?
I got 400.
Yeah, very good. That's correct. And you rearranged to put the 166 and the 134 together?
Yeah.
Yeah, good. And then you add the 12 and the 88 together because they also pair nicely. Right? And the 166 plus the 134 is 300. The 12 plus the 88 is 100. They add up together. 3 plus 1 is 4, 400. Those are two answers. Okay. So this idea of rearranging to make it easy for us is really important, right? Because we're going to have some longer additions now. So for this one, let's do slightly harder problem now. This one. I know you can probably do this right, but it'll take a long time. So try to think of shortcuts. Remember, brackets don't mean anything in addition, just addition, right? But I think of a shortcut. Maybe a pair numbers that are nice. You don't have to take those brackets, right? It's just addition. So for this question, I want you guys to think which numbers pair nicely. And what can I do that? How can I do that? How can I add numbers that pair nicely? That's good. Can you think another way? Shorter way? Can make the pairs the same. You know, if I get this with this, maybe the pairs can be also the 4 pairs the same. Very similar, not much. But just think of another very problem. They can get even nicer pairs. Yeah, that's correct. I don't know.
I'm done with the answer.
The answer, but did you pair them up nicely? If you got the answer, just put it on the like put on the chat there. Right, so that was good. And that's really close. And we just made a small silly mistake working out process. It's really, really close to the right answer. So that's also pretty close. We just gotta, yeah. very
I
good.
did 120.
And how did you get that, Sarah?
I added I added 2 plus 12 plus 22 plus 32.
Okay.
Then I did 8 plus 18 plus 28 plus 38.
Okay. And you just added them together in the end?
So how I did it was I did vertically. So I started with the 2s and
Yep.
then the 3, 2, 1, 2. No, 3, 2, 1.
Oh, okay, yeah. That's pretty shortcut as well, but just from what we've been doing so far, can we do something similar where we pair numbers together that are nicely? Like pair numbers that add up nicely together? So do you remember what pairs with 2 well? What do you want to add to get 0? You're going to get 8, right?
Yeah.
You want to pair a number that ends with 2 with a number that ends with 8, something like that. Or maybe here or here. Then you get easier numbers to add, so you make less silly mistakes. So does that sort of make sense?
Yeah.
So for example, I'll go to one solution, right? So you want to pair this 2 with any one of these. I'm going to pair with this, right? 2 with this 8. I'm going to pair 2 plus 8. Then I'm going to pair the 12 with the 28. That's with 18, right? You could do it the other way. So if you have the same idea, it's fine. You could do it if you have the same numbers. You pair the 22 with the 28. Give me a different color. Right, that's 22 plus 28. So plus 22 plus 28. And then finally, you get 32 plus 38, the other pair. So then you add these individual ones. You get 10 plus 30. 22 plus 28 is 50 plus 70. Or something similar to that. Right? It might not be the exact same numbers. And then you add them up, you get 1 plus 3 plus 5 plus 7, and you just add a 0. If you add the 1, 3, 5, 7, that's 16. You add a 0 at the edge because adding with numbers ending with 0 is really easy. 160. And similarly, it's another way to approach this is to get all the pairs the same. And you can do multiplication, really basic multiplication. What I'm going to do is then put a 2 with a 38. And this is another method to do the same question. Right? I'm not saying your other methods are wrong. And then I pair the 12 with the 28. The easy thing about this is all the pairs add up to the same number now. Because look, you're increasing by 10 here, but you're decreasing by 10. You're just keeping the pairs, all the pairs the same. And then you have the 22 with the 18, you pair the 32 with the 8. 2 plus 38 is 40, 12 plus 28 is 40. You have 4 40s. 40 plus 40 plus 40 plus 40. You can add them. That's one way, but you can also just multiply 40 by 4. That's 160. So that's another way to approach this. And this idea especially is going to be really, really useful in later questions. So you might not get nice pairs all the time, but if you can get pairs that are the same, you can do multiplication. Instead of adding 20 numbers, you can multiply 2 numbers. What do you think is easier? With 4, it's probably the addition is easier. But if you have like 40 plus 40 plus 40 plus 40 plus like 25 times, it's easier to multiply, right? We're going to see that in the hard problem next. So does that make sense, Sarah, right? This idea here, new idea? You want to get all the to be the same, then you can do multiplication. Right? Because that's the idea important for this one. All right? So the challenge problem we're going to do next. This is going to be the big boy question we're going to do now. Right? Okay, I'll give you guys some time to do this one. We'll start with part A. Just part A for now. And then we'll discuss after. I'll give you guys about 5 minutes or so to think about part A. So don't just manually add. That's just not a good strategy because we're going to go to 100 next. So think of a shortcut. You can manually add, but it's not a good idea because we're going to go to 100 next. So think of any way to do it. Make sure that it nicely pairs up together.
So do you just add up the numbers there?
Yeah. Also, by the way, this sort of dot means all the numbers in between. So 1, 2, 3, 4, 5, 6, 7 missing, and then 8. So it also makes 5, 6, 7 there. So this is actually just all the numbers from 1 to 10 set it together. Don't add them manually all the way, all individually. Okay, because that you can do that. It's only 10 numbers, but that won't help you in the next question, which will be 1 to 100. So think about a shortcut that maybe help you. So say and Ryan, does this question make sense? Does a dot 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 make sense? Do you know what that means?
No.
Missing number?
Yeah, that means it's missing. It's sort of seeing the pattern, right? It's adding 1, 2, 3, 4. What do you think the next number is going to be in that pattern? Yeah. And then it just adds all the missing numbers until 8, 9, 10. So just adding 1 plus 2 plus 3 plus 4. So all the numbers to 10. So just dot 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 means continue the pattern. But continue the pattern until 8, so it just adds all the numbers to 10.
Okay.
So does that make sense now?
Yeah.
Wait, I got a question. If you like adding like you know how it's like matches like 4 and 6 equals 10. For like 5, can you like use 5 twice or?
It's only there once. You can just leave it on the side if you want. You don't have to pair everything together. You can do some pairs and then some omissions at the end.
Yeah.
But think of this idea from before as well. You don't need to always get numbers that pair to end up with zeros. If you can get pairs that are all the same, then you can multiply. And I'll come around. Just do whatever's comfortable for you now. Correct. But when you get to 100, I can find pairs like this manually. But think of something that comes up all the time. So maybe just do see a pattern that of the pairs. Maybe like it's correct. I'm not saying it's wrong with it. So think of some pattern that you can use for because you ask you what 1 plus 2 plus 5 plus 5 all the way to 100. You're gonna be able to manually. You still find the pairs manually, right? There's a pattern. Maybe the pair the small one, the big one. So correct. Maybe think of another way to do it. I'll explain it after. You'll make it. Right. So I know you guys want to pair to add numbers that are to tens, right?
I think I'm done. I'm not positively sure if it's the correct answer though.
Okay, can I see the? I'll just check the chat and let you know. Could you, if you submit it on the chat, I'll let you know.
Okay.
Because then if it's wrong, we can keep going, right? Yep, good. That's correct. Yeah, but it's not just the answer; it's about the idea. All right, we'll discuss the idea later on. But
Okay.
the important thing is, I'm going to tell you some new idea now. You don't have to add. I know I told you add up to numbers that pair to add up to zeros, right?
Yeah.
But if you get numbers that pair to get the same number, even if they're not number zeros, you have just a bunch of pairs that are the same, you can multiply. You know, remember that idea from that question? This idea is really important in this question.
Yeah.
So even if you finish it, keep thinking of come up with that idea. But you want to add pairs that are the same, and you can multiply. It's a bit tricky. I want you guys to. The reason I'm not saying it is because if you come up with your own idea to get, you'll remember it better, right? I'm just giving you hints. Even if it's hard, that's fine though. I'll say it a little bit later. That's good. Can you think of? This is but one. Remember how here and altogether. Think about it. Ryan, if you finish, just I'll check. Let me know, all right? Then we can sort of discuss. It's fine if you don't get the correct answer, but it's about ideas here. Oh, yeah. So, yeah, very good. Right, we'll discuss in about a minute. But even if you got the answer, think about a nice way to pair them so that you get nice additions. Because this idea is really going to do some hard problems with it now. All right. I'll just take it.
Okay.
But here's this idea, okay? So all of you got the correct answer, 55. That matters. More important thing is we add numbers, we find an idea. The idea here, to make it super easy, is this. Here you increase by 1 each time, right? If you start with the largest pair, 1 is smaller than largest, 1 and 10. I pair these together. And if you pair 2 and 9 together, what's 1 plus 10? What's 2 plus 9? What's 3 plus 8?
3 plus 8, 11.
Yeah, 4 plus 7?
11.
The pattern now? Then you can use this.
5 plus 6 is 11 too.
So you have 5 pairs of 11.
11 times 11 equals.
Not 11 times 11, that's 5 11s.
Oh, 55.
Yeah, that's another way to get the answer. You see? So it's just 5 pairs of 11. 5 11, so it's 11 times 5.
So my answer was correct?
Yeah, it was correct. Very good. But important, even if you got the answer right, keep this idea in mind. We're going to use that for the next few questions. All right?
Okay.
So you have pairs, the same pairs. What if you go to the next one? Some of the first. Yep, sorry, Sarah.
Find the sum of the first 24 integers.
Oh, yeah. You guys know what integers is?
No.
The numbers.
It's whole numbers. That's just a positive. So it's like, right? So find the first sum of the first 24 whole numbers. So integers means whole. Integers could include negative as well, but so you're just asking to find the first positive 24 whole numbers added together. It's just also, do you know what sum is?
Addition. Addition.
Addition.
The answer when you add all the numbers together. Sum of the first 24 means you add those two numbers together, and whatever the answer is, that's the sum. Yeah, yeah. So it just means when you had 1 plus 2 plus 3, all the way to plus 21 plus 22 plus 23 plus 24. What's the answer? That's what the question says. Now, can you guys do this one? Same idea. Think of the idea, right? Because you can't do this manually. Too many numbers. 24 is way too much. So it should be multiplication at the end, right? Because you have numbers that are pairs.
I've got both of them.
Got the answer? Oh, you did both of them. Okay, nice. Okay, let me. I think that's correct. Let me just give me a sec. Yeah, they're both good. Very good, Ryan. How many pairs are there? How many pairs are there? The 24 pairs. There are 10 numbers. How many pairs do you have? Okay, we'll go back here. Yeah, 10 numbers, 5 pairs. 24 numbers, how many pairs?
Do we do this one or do we do that?
You can get started. Yeah. We have a break now, but so you can get started now. We'll let's look later. So yeah, that's close. But I want you to think about pairing the numbers up and doing a multiplication.
Okay. I'm just doing the second one.
Doing the second one?
Yeah.
Okay. But for B, it's not 130. So I want you to like just think about the first question and just apply it again to this next one.
For C, do we
Okay.
start from 6?
So
Or do we just start
you start from 6, yes. So 6 and then all the numbers in between 8. So for B, I want you to guys think of pairs, right? The pair is 1 plus 24 is 25. When you pair 2 and 23, that's also 25. When you pair 3 and 22, that's also 25, right? For this question. So we have pairs of 25s, right? How many pairs do we have? That's the question. Ryan?
Awesome.
I did it a different way.
Or how'd you do it?
So basically, I did the first number with the last number. I did them.
Yep,
So
25.
6 plus 15.
Sorry?
6 plus 15.
Oh, for C. Talking about B.
Oh, wait. For B, then so I did 1 plus 24.
25, yep. And what did you do after that?
And then I times it with the numbers of I times it with the numbers in the how much numbers there are in the thing.
Oh, how many pairs?
Yeah.
Oh,
No.
24. Okay. And then what did you do after that?
600.
Yep.
And then I divide it by 2.
And why did you use that formula? That's correct. I don't see anything wrong with it, but
Send some ads. I send the
answer.
the A again. I sent A again. I'm sending B.
So Ryan, could you explain your formula? It's correct formula. Do you know this formula from before?
My dad just told me.
Oh, okay. All right. That's a formula. It's a good formula. It's correct. It's n times n plus 1 and 2. It's a formula you can use, but it's a very similar idea to that. It's just how many pairs there are and you divide by 2.
I said B.
Yeah, all right, good. I'll take a look. So yeah, that's another way to do this. But the way we do, from what we learned so far, the easiest way is just to do 12 pairs. I'm nothing wrong with this. I like the way it's really good. That's correct, 300. Well, the other way is to see 12 pairs of 25. So that's 300. Oh yeah, very good, Sarah. Good job. It's really nice.
I did what you taught.
Yeah, so that is really good.
Thanks.
Yep, so that's 24 numbers. That means there's 12 pairs, right? 24 numbers, 12 pairs. That means it's 25 times 12 pairs, 300. Does that make sense how there's 12 pairs? Yeah, so there's 12 pairs. All that up to 25. So just multiply them.
Okay.
So Ryan, your method is completely fine. That's good as well, right? That's formula you can use. But this is the idea behind the formula. But, okay.
Okay. 6 plus 4.
We'll discuss this after. Most of it, actually, we'll discuss it now, right? We have numbers, we have pairs. Again, the pairs are now, there's pairs of 6 plus 15, 7 plus 14, 8 plus 13, 9 plus 12, 10 plus 11, right?
Equal. So that
All pairs are
5.
It's 21 times 5, which is 105. That's the answer to this one. Alright, okay. Does that make sense for everyone? How we got these two answers?
Yes.
Okay, good. All right, we'll have a 5-minute break now, and we'll come back and continue with this stuff, right?
Okay.
So see you guys at 10:15 or 10:16.
Okay. Bye.
So it's just having an idea, generalizing it more and more. That's why it's tricky. Don't worry, just chill.
Yeah.
So class makes sense of that. Class makes sense of that. Do you like it? Ma, do you have your test on you?
Sorry?
The test you did?
Oh, yeah, did it not go through?
It uploaded, but it didn't have any answers on it.
Huh?
No.
Some of the questions, like 2, I didn't do because I didn't understand.
Oh, okay, yeah. Okay, I'll take a look and see if I can, and then
Yeah.
maybe I'll give it to you later, and then we can. So I just want to see if you're ready for the topics. It's fine if you don't get it. We're gonna learn this in class anyway. That's not a big deal. When's the F1? I want to watch this.
2 more minutes.
Yeah.
Sorry, Sarah, you say something?
2 more minutes until break ends.
Yep.
Those ones mostly are not answered.
Oh, okay. All right. When you get it like at home, so we can scan with the thing. Right? Then I'll mark it and I'll see. I'll let you know anything if you need to do extra questions. What do you guys watch any sports?
Let's see.
For me, who do you like? You like what's his name? Carl Chalmers?
I like Michael Phelps.
Oh, well, he's retired, isn't he?
Yeah.
Oh, but you watched him like when he was,
Yeah, like, but still, didn't like a 10-year-old like 4 years ago break his record for like butterfly? Apparently, a kid called Clark Kent did it.
Clark Kent.
Yeah, that's
Like
his actual
Superman.
name.
Wow, I don't know. I've only seen what's a big race in the Australia one? What's her name? Katie Ledecky
Yeah.
versus Ariane Titmus. That one was crazy. I was watching it at school, and everyone was watching it. It's so good.
I'm pretty sure she didn't she like swim in the 2020 Olympics?
Yeah, that was the Olympic race. Yeah, everyone wanted to watch that. It was like really hyped up. Okay, it's 10:16, so we'll get started. All right. Ryan, say, are you guys there?
Yep.
Yeah.
Okay. What about you? Yep. Okay, good, Ryan. So we'll get started now. So we're going to finish up addition with these last two problems, right? First question, D, is to find the sum of the first 100 integers, so positive integers, I should say. So integers means whole numbers. It could be negative as well, but positive means you only count first 100. So it's 1 plus 2 plus 3 plus blah, 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 all the way until 97 plus 98 plus 99 plus 100. If you add this manually, it's going to take you ages, right? So again, we're coming up with an idea, maybe pairing them up nicely to find what this sum is.
1 plus 100 equals 100 and 101
Yeah.
You have to
times 50.
if
Must
there's
be 50.
don't have like 50 like pairs, and then you can just times it.
Yeah.
Yeah.
That's the idea for this, because you can't do it otherwise.
Yeah.
Yep. Sorry, what were you saying, Sarah? I was asking someone else's question. Sorry, what did you say there, Sarah?
The number might be 101 because 1 plus 100 equals 101. 3 plus
Oh.
99 equals 101.
Yeah. Oh, okay. The special number is 101. Yes. And how many of those are there?
I'm not sure. I think 50 or something.
It is 50, right? There's 100 numbers. That means 100 divided by 2 is 50 pairs.
Okay.
Because remember, all the numbers keep pairing on to 50 and 51. So it's 101 times
Got
50.
the answer.
Yep. And then, very good, Ryan. So say I keep going with that question. You're on the right approach. It's good as well. Just keep going and you should get your answer. Have you finished? Go to E. It's a bit tricky. Just maybe write out 1 to 2n and then see which numbers pair up. So you don't know what n is, but just pretend like you sort of know and just think. What is it 2n? So we don't know what n is. It could be like 20, n could be 20, it could be 100, it could be a million. But we just you can do I'm just saying you can do the pattern anywhere, 20 numbers, right?
But so I can do like
Okay, got the answer.
Just give me a sec, I'll explain. Yeah, good, sir. It's very good. So what I mean by this is for part E, you should be writing 1, 2, 3, 2n minus 2, 2n minus 1. 2n. It's the same idea as one before. We don't know what n is, but we can still do pairs, right? We can pair first one and the last one. What does pair add up to, right? And how many pairs are there? Because there's two n numbers, the number of pairs is.
I don't know how to do 2n integers.
We just formula for n, so any number n. So we're not gonna find n. Yeah. So does that make sense a bit more? So Sarah, this is a bit tricky. Is that you don't know what n is.
Yeah, I don't
But you're still
know.
gonna, yeah, you're not meant to know what n is. You're not gonna, like, the question is not to find n. It's to find a formula for the sum of the first two n.
Okay.
So what I mean by that is, you write, just do the same thing as you did with the previous question almost. You pair the numbers. 1 pairs with 2n, right? 2 pairs with 2n minus 1. 3 pairs with 2n minus 1, 2, and so on and so forth. And those pairs add up to then 2n plus 1. Right? Each pair adds up to 2n plus 1. Right? Does that make sense?
Yeah.
Any questions for anyone? Oh no, it's all good. But how many pairs are there? There's 2n numbers. Remember, when there's 100, it's 50. When there's 10, there's 5 pairs. There's 24, there's 12 pairs. There's 100 numbers, it's 50 pairs. When there's 2n numbers, how many pairs are there? What do you do to get, when you have 100, you divide by 2 to get 50, right?
Yeah.
If you have 2n, what do you get when you divide by 2? 2n, oh, sorry. I should explain what 2n means. 2n means 2 times n. I think you might know the algebra.
Oh,
So how many numbers are there?
2.
None.
Oh, so basically 2 times we don't know.
Yeah.
Oh, okay.
Does that make sense? Have you seen that before?
Yeah.
2n means. So how many pairs are there? It's 2 times n pairs.
So it's an unknown amount of pairs.
Yeah.
I have never seen 2n before.
Okay, so 2n doesn't mean like 2 and then n, like as in numbers. 2n means 2 times n numbers. Right? So there's 2 times n numbers. The number of pairs is 2 times n divided by 2. Cancel, cancel. N. Number of pairs. We don't know what n is, but it's a number, right? Does that? That's a bit weird. Any questions? If you have questions, let me know. This is a tricky idea.
How would we find out the answer if we don't know how much? Like,
We don't find out the answer. We just leave it as a formula in terms of n. And then when we have a number n, we can sub it into the formula. Does that, other than that make sense, right? Yeah. So there's n pairs, right? And 2n plus 1 in each pair. So 2n means 2 times n again, not 2 then n, right? Then it means n times 2n plus 1, which is, you can leave it as, you can just leave it as 2n times 2n plus 1 is your answer. Right? And I'll show you how powerful this is, right? Now, if I sub in, if I say n is 12, right? That's the sum of the first 2 times 12, which is 24 numbers, right? Which is what we did before. So we should get our answer to be 300, right? I just subbed in n is 12, right? That means the first 24 numbers. If I sub in n is 12 into this formula, look at what happens. N is 12, that's 12 times 12 times 2 is 24 plus 1. What's 12 times 25? No, close. You can do long multiplication if you want. You don't have to in your head.
Didn't we do this in like part B?
Yeah. 12 times 25 is? Do times 10, then add 2 times. So Ryan, what? Yep.
150.
No, 12, not 12 times 25, not 6. It's close.
12 times 25. 250.
No, that's times 10.
Oh, 300.
300. 12 times 25 is 300. And if you go back to our question from before, that's the answer here is also 300. So you just had a formula to find the sum of the first 2n numbers. So if you just sub in the number of n you want, you can figure it out. So if you sub in, if you want to find this 100, sub in n is what? How many? What do you sub in for n here? So look what I did. To find 24, I subbed in n is 12. So here I subbed in n equals 12 into this one. If I want to get 100, I will sub in n equals. No. So we're going to find this. This is the formula for the first 2 times n numbers. So to get the 100, I'm going to sub in n is 50, then sum the first 2 times 50, which is 100 integers.
Oh.
So n is 50. If I sub that into the formula, I get 50 times 100 plus 1, 101. And I get this answer again. So I just created a formula to do the same question as this. But now I can sub any number. If I want to find the first 96 numbers, I sub in n is, what is it? What is sub in for 96?
Okay, for 96.
Which value of n would you sub in to find the first 96? So remember, when you want to find the first 24, we sub in n is 12. When you want to find the first 100, we sub in n is 50. Let's say we want to find the sum of the first 20 whole numbers. 20. What value of n do we sub in?
10.
Yeah. Then you sub into the formula, you get sum of the first 20 numbers. So if I sub it, so this is a formula here, n times 2n plus 1. I sub in n equals 10. And I get 10 times 20 plus 1. That's 10 times 21. That's equal to 21. Yeah. Just add 0 at the end. Sum of the first 20 whole numbers is 210. And you can do it with any number. You sub it into the formula, you get this answer. Right? So that's a shortcut, I guess, you can use. But we're not, it's just, this is called generalizing, right? We had an idea that we used for normal numbers, then we use for any number n, right? So we can then just sub it into formula. Figure it out. Okay, so this is called generalizing. We're going to do this a lot more later. This is the most important idea in maths, generalizing. All right, okay. Now we're going to subtract, oh, sorry, multiplication, not subtraction. Okay. So multiplication is a little bit harder than addition, right? Not too hard, but you know, it is a bit, takes a bit more time confusing. But the properties are very, very similar. See how we learned the commutative and the associative? They're still very similar to multiplication. There's one more extra one, but I'll come to that later. Right, so this is the basic definition of multiplication. It's an operation that means repeating addition. Oh, sorry, I'll get rid of that. Right, so if I'd have 6 times 5, that means I add 6 5 times. 6 plus 6 plus 6 plus 6, that's 30. Right, just like that, you know. The basic multiplications should still be like we can do in our head.
6 times 5, or you can do 5 times 6.
Yes, you can rearrange them just like with addition. And we'll talk about that later as well. Very good. All right. So we can do the basic ones in our head, right? So 2 times 5 is 10. 3 times 8 is 24. Any number a times 0 is 0. It doesn't matter what a is. It ends up being 0 all times. Any number b times 1 is b. It just stays the same. Does that make sense? You multiply by 1, the answer doesn't change.
Okay, I understand.
So it stays as b. So this is important, two properties. When you multiply by 0, it always ends up being 0. Multiply by 1, it doesn't change the number.
Okay.
Right? Not that one. But multiplication gets bigger quicker than addition, right? So we need to start using long multiplication or vertical multiplication much earlier with smaller numbers, right? So, but still you got to be careful, and you need to know your timetables up to 10, 10. 10 long division is pretty straightforward. Right? Just you gotta not be careful and not make silly mistakes. Right? So let's do. Actually I'll do this example. I know you're going to do this, but for example, to do 17. Sorry, Sarah, did you say something?
I was actually reading the question.
Oh, okay. All right. So yeah, it's 17 times 19 times 1, right? And then to make it simple, we'll first of all ignore the 1 to change the answer, right? Yeah, keeps it the same. So we're just going to do 17 times 19 vertical multiplication. Right? And to do this, we do 9 times 7 is
9 times 7 is
63.
63.
Yep, very good.
1 times 9 is 9 plus 6 equals 15.
Yep. And then bring a 0 now because you multiply by 10. And then
1 times 7 is 7.
Yep.
And 1 times 1 is 1.
So then you add these together.
3.
Yep.
2 and 1 up there, 3.
3, 2, 3. Right? So it's long multiplication very similar. Right, and then this one, when you have more than two numbers, what we should do is you can either do them separate long multiplication, or you can make it even simpler. You can just pair one of these together. Make 23 times 2 into 46. So what I mean is you can either do them like separately. You can do 23 times 37, then you get an answer. And you times that answer by 2.
Smile face.
Or for B, you get another one. You can do some of them in your head, right? 23 times
Okay.
46 times 30. We can do there. And then we can do this is one multiplication. They both give them the same answer. Right? So for example, actually I'll let you guys do these three questions. Do this example B here. And
Okay.
then next guys 2. So there's 3 questions I want you guys to complete. Give you guys about 5 minutes. Okay. This is just warm up, so you shouldn't have it already.
Okay, I check the answer. I did the answer. I chatted it.
Okay, I'll take a look. So, thanks for letting me know. So is that the first one? Is that sorry, wait, give me a second. My app's lagging. All right. Is this one? Sorry, this one?
Yeah.
I was seeing those close. Let me see again. Oh, it's close, but not exactly. How comfortable are you with long multiplication, Saya?
Hmm?
You know long multiplication? You do, right?
Yeah.
Okay. You've got to be careful when you're working. So you got to do 23 times 37. Right? Let's do this together if you want. Oh, sorry.
Okay.
Oh no, my app disappeared. Give me a second. My app crashed. Okay, all right. 23 times 37. What's 37?
So 7 times 3 equals 21.
1, then carry the 2, right?
Yeah.
7 times
And
2.
then 7 times 2 equals 7 times 2 equals 14 plus 2 equals 16.
Very good.
Add the 0.
Yep.
3 times 3 is 9. And 3 times 2 is 6.
Yep. And you add these together and you get
1, 5, 7.
carry the 1, remember?
Yeah.
Plus 9 is 16. 1
7.
2 plus
8.
no.
8.
Then you multiply that number by 2 and you get your answer.
Okay.
Just be careful when you're working. All right, so you did this really nicely. That's good. This is a similar method. Just be careful when you're working there, okay?
Okay.
Good. So I'll see how you guys went. Yeah. Yeah, it's fine. Yeah, it's fine to do in order. And we'll explain why they're the same. That's a property, no addition, rearrangement.
So the answer for the other one is 1,702.
Yep, that's correct, Sarah.
Yay.
And Ryan, have you finished them? If you finish, just put them on the chat or just let me know, all right?
Okay.
I'll just do those two as well.
This should be straightforward, right? Yeah. And if you guys confuse what product means, it means the result when you multiply two or more numbers. So in the question I said products. Products just means the answer when you
The answer.
right with the multiplication. Okay, so we'll go through this one. I'll see what left. Which one is that, Ryan? Is that B? This one?
So
A
is
is
Wait,
4.
sorry, Sarah, could you just let me? Can you talk after this? I'll talk to Ryan first. Is that fine?
Okay.
Thanks, Sarah. Sorry, what were you saying, Ryan?
So A is 612 and B is 600.
With this A here?
Yeah.
It's a bit bigger than that. Gotta be careful. So just be careful when you're working this. Actually, let's start going through this. And so I think what you're saying sounded right. So it's good. So 42 times 34, right? 40. All right, so to do this one, we do 4 times 2 is 8. 4 times 4 is 16. Keep going, right? 0. Then you have 3 times 2 is 6. 3 times 4 is 12. You add this together. Right? And when you add this together, you get 8. 6 plus 6 is 12. Carry the 1. 2, 2, 4. 1 is 1, 4, 2, 8. Okay? And then, because you multiply that by 3 at the end, you just multiply this by 3. So 1428 times 3.
So
Four.
that's correct.
You are correct, Sarah. Very good. Carry the 2. 2 times 3 is 6. Carry plus 2 is 8. 3 times 4 is 12. Carry the 1. 2 times 1 is 1. Carry plus 1 is 4. So does that make sense, Ryan?
Yeah.
So just be careful with your work, and I'll just give you a couple of minutes to do this one, and let me know what you get. All right? Questions for you guys?
The B is B 5,246.
Yep. Very good, Sarah.
Okay.
Yep. Go here around. Okay. See the door there?
Oh,
Yep. Right there. See the door right next to the kitchen one?
Yeah.
All right. So we'll move on now. Shall wait for Johnny to come back, but the answer for this one is 5246. So you haven't got it yet, keep working, and if you get just until make sure you get this answer, right? And if you have any other questions, please let me know for this one, all right? Because I want you to be followed with the multiplication basics, okay? We'll wait another minute or so. We'll just wait for the students to come back. Now we'll move on. Okay.
I think it's like 9 more minutes. No, not 9.
Close.
19.
Yeah, 19 more minutes. Then you guys are free. Okay.
Okay.
All right. So just like when you do addition, multiplication also has properties that you can use to make calculate really easy. Okay. So there's 3 main ones. You know how addition we had 2, the commutative and associative. We have those 2 again. We have extra one as well now. We have extra one, just distributive property. When we use these 3, then we can use it to make really big multiplications, small ones that we can calculate on our own. Right? So that's what we're going to do today for this one. So the first one is, I want you guys to calculate these 2 really easy questions. What 3 times 6?
3 times 6, 18.
What 6 times 3? What about
18.
Yep, very good. So my question for you guys is, does it matter the order we multiply the numbers in?
No.
The order doesn't matter. Just like in addition, you can rearrange. So we're just talking about how you can rearrange. Okay, we can
But
talk about-
only in subtraction and division.
Yeah, exactly. And we'll come to that as well. We'll figure out a way to make a shortcut with those as well later. All right? That's
Alright.
next week. So that means commutative property of multiplication means A times B, any number A times any number B, same as any number B times any number A. So it doesn't matter which one goes left, you can rearrange them. Just like there's a visual of that is 2 times 6. It doesn't matter if you count 6 groups of 2 apples or 2 groups of 6 apples. They're both 12. So that's the idea for that. So I'm guessing it makes you've got seen this before, right? Another one. We'll go to the second one, which is the associative property. Any questions with this, Janet? Or
Oh, no.
nice, sure, right? All right. We'll go to this example. Let's calculate 3 times 2 times 5, except you do 3 times 2 first. So it's 3 times 2 is 6, times that by 5, 30. Here we do 3 times by 2 times 5 is what?
30.
Yeah, 10. And then you multiply that to get 30, like you said, Sarah. Okay?
Yeah.
And then again, I ask you, does it matter which of the 2 multiplications here we do first? No.
No. You can do it second. Wait, no, not second.
You can do second.
Oh,
do it
right, you
any-
can do second.
Yeah, you can do any order and you'll just see the answer the same.
Okay.
So look, here I did 3 times 2 first, here I did 2 times 5 first. They both give me the same answer.
Okay.
So that means associative property of multiplication is A times B times by C, same as A times B times C.
A times B times C equals A times B times C.
Yeah, I just means the brackets don't matter, is what I'm saying.
Okay.
And if you, this is the example is, you can count it different ways, right? You can count it as 2, each die has 2 by 2,
12.
right? Because each die has 2 rows and 2 columns, that's 2 times 2, and it times that by 6. Or you can do 4, each die has 4, then you do 2 rows times by 3 columns. Or you can do 4 times 3
Four.
times 3. It doesn't really matter which order you
4
do.
times 3 equals 2.
So in the answer, in the end, no matter how you do it, it's always going to be 24.
Yeah.
So that's the important property of this. So again, just like addition, we need to figure out how to use this, right? How to use these properties. So when we have the way we use this property is we rearrange to multiply together numbers that pair nicely. right? So for example, not forming nice numbers that end with zeros, right? As you guys all know, multiplying numbers that end with zero is super easy, right? Because you just multiply the smaller number, then you add a zero to it, right? 25 times 10, 20. Say 25 times 2, which is 50, and then you add an extra zero to it. So if you can find numbers that pair up to multiply numbers that end with zeros, it's really easy for us. Just like when you add, you want to find numbers that have zeros. All right, so again, this means you can do multiplication in any order. So you should arrange it to make it easy for yourself, right? And again, when you have multiplication only, you're allowed to ignore brackets. Right? Brackets don't mean anything. It's just multiplication. Just multiplication. No multiplication addition, just multiplication. Okay. But to be honest, these two properties are not distributive, associative. These two properties, just for multiplication, is less useful than it's for addition. So we're not going to do too many problems with it. We'll go to this one. I'll go through this example. Right. So 4 times 17 times 25. Right. So we can do this left to right, but is that shorter way?
No.
Huh?
You can also do it right to left.
Yes, but we can rearrange to make it easy. 4 times 5.
So 4 times 25 times 17.
Then 4 times
Brackets.
100.
So that's 100 times 17.
And just add 17, then 2 zeros. That's your answer.
Okay.
But did you do it the easy way or the different way?
I did.
Yeah. But so just get used to this one. So I know you can do the other way as well, but it's about getting the method. So
Okay.
you see this method is easier, right? Let's big now. Just like that same thing here. I'll let you guys do the same idea for these two questions. You can do it by yourself the other way, but try to compare shorter method so that it will help you. All right? Do A and B here. It's good idea, Johnny. It's a really good idea, came up. So this idea makes sense. I want you guys to use this idea for the next two as well, right? So you rearrange to get nice numbers. That's my hint for you guys. Gonna make it easy. So would it be easy if you find numbers that pair up nicely first? You got it correct. But just like you did here, we rearrange. You ignore the brackets, right? Do you know how to rearrange there to get 4 times 25?
Yeah.
Same thing here. Get numbers that pair up to end with zeros.
Isn't that already like 7 times 25?
I know what the plan is. I'll just chat it.
Oh, you put it on the chat. That's good, Sarah. But if you do 8 times 25, you have a number that ends with zeros. You have a number that ends 5 multiplied.
I did your order.
Oh, that's good.
I'm just setting it.
Right, put it on the chat. Okay, I'll give you a hint. Even numbers and numbers that end with 5 always gives numbers that end with 0.
True.
Yep, very good, Sarah. How are you going with these, Ryan?
Oh, good.
I could do 8 times 25. That's
Yeah.
200.
Then you multiply by 7. It's pretty easy to do that, right? 200 times 7 just 2 times 7. That's zeros. So Ryan, what's your answer to part A?
So for part A,
Yep.
is wait, part A is
If you're not sure, that's fine. I'll give you a couple more minutes. Fine. Okay. Johnny, what's your answer to part A?
1,400.
Yep. It is one.
A is 1,400.
Very good, Ryan. Your answer is you have two people that agree with the same answer. So actually 3 people and 4. Actually, all 4 agree. It's 8 times 25 to rearrange it like this. This makes it easier. Even numbers and numbers that end with 5 always pair really well. Right? So 8 times 25 is 200. You can calculate long multiplication if you want. But 200, multiply that by 7, you get 1,400. And then I'll give you guys a little bit more time to do the hard one. Again, if you do this manually, it can take a long time. Come up with pairs. Make it nice.
Just got started.
Wait, if you have even numbers end with 5, they can be. Because when you get you get a nice number. Don't multiply these two. Let's take it out. Multiply these 4 numbers. Okay, so does this all make sense? Do the nice pairs first. So for this one as well, you should do numbers that pair nicely.
B is
Yes.
I'm not sure if it's correct.
Can you put it on the chat? So I'll just take a look because other people are still doing the question. Is that fine? I'll take a look then, Sarah.
Okay.
Thanks. Thank you. Very good, Ryan. So you can results by like that. 3 multiply those numbers. So you got 270. So you can just ignore the zeros and just 75 times 2. Your answer was right until you added it. You just need to change that.
Okay.
Okay, so I'll take a look. Oh, it's a bit small. It's close though.
Okay.
So think of the pairs, right? For example, I'll pair 25 with 4. Maybe I'll pair 125 with either 6 or 8. I'm going to actually be doing with 8 because I think that's a bit nicer. But even if you do 6, it's not too bad.
Okay.
25 times 4
Mm,
is 100, right?
yeah.
125 times 8, if you calculate that, 0, carry 4, so 16. 0.
16, 20, and 2, 3.
8 times 1 is 8, plus 2 is 10.
Oh, yeah.
There's 100. This one's 100.
So,
And you're also missing another 6. In
times
the,
6.
it is multiplied
6.
3 zeros, 2 zeros, that's 5 zeros total. You need to add the 6 at the end.
6.
Really big number, 600,000. Is that confusing or does that make sense?
Makes sense.
Make sense? Okay,
Yeah.
so I'll put a bit more practice questions on the homework as well, so it should be fine then. All right.
Sure.
Okay, just before we finish, we will go to the next property, which is a distributive property. And actually, before we move on, do you have any questions with what we did, the last couple of questions?
Right.
We have 4 more minutes.
Yep, sorry, give me a sec. Who that was, sorry. Yep.
I times like 4 and 6 and did it.
That's fine, yeah.
Yeah.
If you get, it's a similar idea.
So like if it was an exam, would you like lose points?
Yeah, it's good. It just shortcut. It doesn't change. Yeah. So who was that? Sorry, I didn't hear that exactly. I was talking to another student. So what were you saying? So was that Ryan? Yep. Sorry.
There's 3 more minutes.
Yes, we might go a little bit over time though. That's fine with you.
It's okay.
Okay. Thank you. All right. So now I'm going to start with distributive property. All right. So we want to find the total number of squares, small squares in the following shape. Yep. So you might not know the color exactly. Actually, you have separate, right? You can see the different colors.
Yeah.
All right, so it's red and blue, but you find that black and white might be different. All right, so the way we can count this, we count the red squares, which is just 1, 2, 3, 4. I'll use the thing. 1, 2, 3, 4, 5, 6, 7. 7 times 3, which is 21. I'm just gonna leave it 7 times 3. Don't worry about 25 for now. What about the blue?
7 times 5, which is 35.
Yeah, good. It's 35, but I'm gonna leave it 7 times 5.
The total for red is 21. The total for blue is 35.
I'll leave that. Don't worry. Total doesn't matter too much. But to
Okay.
get the total, we can add the blue and the red together, right? 7 times 3 or 7 times 5. Just like that. But if we just ignore the colors, we just want to find the total, we just add the whole thing all the way, right?
56.
We have 7 rows, so 1, 2, 3, 4, 5, 6, 7. And how many squares vertically in this? In the total?
4, 2, 3, 2,
Two.
4,
5, 6, 7, 8. Right?
8. Yeah.
But yep. So it's 7 times 3 plus 7. Or we can also do 7 times 8 directly, because there's 8. 8 on this side and 7 on this side. So you know what that means?
Which is area.
Yes, it's area, but it's also the idea. This is not the area, but the mathematical idea is that these two are the same.
Yeah.
7 3 plus 7 times 5 is same as 7 times. So I'll just leave it as shall do 3 plus 5. It is 5. 7 same as 7 times 3 plus 5. So this is really important. This is a distributive problem. When you have 7 multiplication over 2 addition, you can just do the addition separately, is what it's saying. From that picture, just from that picture alone. Right? So we'll come to this with our picture, right? But this property, the way we talked about it, does it sort of make sense?
Yeah.
And we'll go through this more. I'll show you a video as well, then we'll finish. All right, so next one is, what's 3 plus 7 times 4? Yep, it's 10 times 4, which is 40.
And,
What about 3 times 4 plus 7 times?
3 times. It's the same answer.
Yes, same answer. The 12 plus 28. which is 40. So that means 3 plus 7 times 4, same as 3 times 4 plus 7 times. Yep, sorry, what would you say there?
I was just saying the numbers.
Oh, okay, yeah. But do you think this will work with any three numbers? If I should give you this, A plus B times C, would that be equal to A times C plus B times? Do you think that's what's going to happen? Yeah, right? This is called a distribution, where you can distribute the multiplication of both numbers inside the brackets. A times C plus B times C. Right? So we'll leave it at that. We'll do more problems later on. And I really recommend you guys watch this video for homework. I'll send this video on the homework thing. Right? It's a good video on it.
Do we just go to like a Google Classroom like that the form and then we just push it on that like on device?
Yeah, and on the handout, if you click this, because this is my like writing PDF, but if you go to the actual handout, click the video, watch this video here.
Yeah.
You'll see the exact video. It's a really good video.
Okay.
Okay, guys, we finished it there. Do you guys have any questions?
No.
Do you guys like today's class?
Yeah.
That's good.
Yeah.
All right. Okay. If you have any, I will upload the home. I've already uploaded the homework, I think. So please complete that, right? And also, there's what's it called? On the homework, there's like a little. I'll show it. I don't have it. Never mind. But on the homework, there's a first page that shows you how to set up Alchemist, because Alchemist is really, really important, right? Because this week I've given you some questions on the sheet.
That's online for us.
Yep, it's online. I'll put it online for you guys. Yeah, but I'll give it to you.
In our school, we do maths online for our online homework.
Oh, nice. That's cool. Do you like that?
That's good. Yeah.
It's similar to this. This is a really good website, but just for this week, because you haven't set it up yet. There's paper homework as well. There's like a handout for the homework.
So do we
Yeah.
have like Alchemist and this?
This week both, but next week on is probably gonna be done. All right, just because you haven't set it up yet. All right, so you'll have to create an account, but then you need once you create an account, you need to get your parents' permission. You need to sign a form and send it to their email. Then they'll verify your account, and then you can use it.
Like tell like the data and stuff and it's in like an email.
Oh, I did. I sent you them. So if you want, you can there's an email sheet with all the information. I'm just telling you guys what. So just let your parents know there's an information sheet with all of the information on how to set up Alchemist, and they'll set it up for you. Then you can start doing it for next week on it.
But I have a question. Like in my school, we use like Star. Like there's like this online like school thing. Like you had to join the class.
Yep.
So like for like you, do we like join Alchemist and there's like this class like we joined like we
Yes.
hosted?
I have a classroom, then I can see how you guys are doing with the questions.
So will there be like a code for it?
Yeah, there's a link I've attached on the Google Classroom as well.
All right.
We'll finish up there. If you have no other questions, do you guys have any other questions, Ryan and Sarah?
No.
All right, okay. Then please get to the homework. Hope you guys have a good week, and I'll see you next Saturday, okay?
Bye.
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 Week. All right. Stop the share. Stop recording.